Okay, welcome back everybody. Thanks for joining me again. So this is the fifth video, I think, in the series where I'm trying to learn the Rust programming language. You'll sort of probably join me fumbling along, I hope at least, trying to learn Rust, but applying it to a particular problem. I love learning things with an application rather than just learning a new language in isolation. And so for those of you that haven't joined before, I'm using Rust to apply or to process and understand and parse a data format that's used quite commonly in astronomy called fits. And so in the last video we got to a useful point I think, where we were able to read files, sort of open them, read them in entirety into a vector of bytes, and then start understanding what the fits data structure looks like using the NASA spec on their website, and then also start writing code to parse the fits file according to that specification. Now we've got a GitHub repository here called fits-rust. You're more than welcome to have a look at it. It links off to the fits NASA website. And this markdown sort of document shows us a bunch of things that we want to achieve. And so we've gone through quite a bit of this already. We've certainly started parsing. We've covered a subset of basic Rust. And we're writing code now that actually works and does something useful. So if I go back to where we were last time and try and run our existing program, you can see cargo run returns, well, firstly it compiles and then it returns a welcome message, and it tells us how many bytes we read in that file, our test file. And it also starts showing us that we found a header, which is what we did last time, and the number of records inside of that header. But what I had after the last video was some really good feedback from a couple of people. One person in particular, who is clearly a deeper expert in Rust than I am, gave me some really, I think, quite helpful tips around how to write more idiomatic Rust, but also how to just write better code using Rust. And so I took that to heart, learned quite a bit from that, so thank you to that person. And I wanted to share some of those things. And so today is more about perhaps refactoring what we have, as well as expanding the parsing aspect. We're not going to get into understanding the data and the binary data and displaying and rendering that. That is, I promise, something for the next video. We will get there very, very soon. And we want to get there because we can render some really beautiful images because we're looking at Hubble space data, Hubble Space Telescope data. But today we're going to really sort of improve the quality of the code we're writing, learn from some feedback that we've had, and start writing better Rust. And after all, that is the point of this whole series. And so what I'm going to do is kind of cover off the first couple of things that this person sort of shared with me. The first was that there are a couple of components that I can use, that I can add to my runtime that will improve how I write Rust. And the first one was called Clippy. So Clippy is a helpful tool that sort of introspects the code that you're writing while you're writing it. Certainly if you're using Visual Studio Code, you can have Clippy sort of giving you hints as you go. And it will give you sort of advice around best practice and idiomatic Rust. And I really like that. So as a beginner, that's really helpful. So you install that using rustup, rustup component add Clippy. I've already done that, so that's installed. The next one though was something called Rust format. And this is a formatter for Rust. I am still learning Rust, and so I don't really know the idiomatic way to do the formatting, but this component helps by actually doing the formatting for you. So it can, in the case of Visual Studio Code, you can configure a formatter on save, which I've done, and it will automatically reformat your code and sort of make it look more beautiful. You can also run that with Cargo. So to install that component, again, rustup component add rustfmt for Rust format, and that's already installed. Now what I can do is I can run these components with Cargo. So I can say within my my project here, fits Rust, I can say cargo Clippy, which is great, and it'll give me a whole raft of advice telling me how terrible I am at writing Rust code. And so we'll go through that and sort of address those points today. But the other one was cargo Rust format. Now, before I run this command, because it's going to actually change my source code, I'm going to show you over here on the left-hand side on the screen here. You can see that I'm using match, and I've got for loops, and I'm sort of chaining these functions together, and they're doing a whole bunch of things on iterator, and anyway, and so you sort of see quite long strings and using return. And anyway, I'm writing some basic Rust code, yeah? So what this thing will do is it will apply a kind of a best practice template. And so as soon as I run cargo rust format, it's going to modify my code. And so I'll run it there. Might be just cargo format. Sorry, cargo format. So cargo FMT, and on the left-hand side here, what you can see now is it's made the code a little bit more beautiful. It's changed the match expression, and it's wrapped lines, and where I've chained things together, it's kind of broken those onto new lines. And so we're going to use this throughout the day today, and we're going to sort of learn how to write better code. And if we still get it wrong, then at least the formatter will help us. All right, now let's go back and run our actual code. Well, firstly, let's save that nicely formatted file, and what we're going to do is just do cargo run. So this will build our code and run the code, gives us a welcome message, tells us how many bytes it read from the fits file, and then also tells us that it found a header and the number of records in the header. Now what I'm going to do today is I'm going to go through some improvements to this code. Okay, and so the first improvement that I got from the feedback from the last video was that I can improve the way I do error handling. So this is quite a verbose way to do error handling in Rust. It's flexible though. It certainly lets you completely manipulate and customize the error messages that you get and what have you. But if we remember that read to end was basically going to read the entire file until it found end of file. File open above that was going to just open that given a path struct. What we can do is actually simplify this quite substantially. And so if we look at the code, we have an example fits file here, which is in my project under the data folder here. We've got two different ones. We're using this one that starts with HRS, and then we've got we declare a variable called file, and we do match. And if we and because file open returns an IO result, there are two things we can match on to destructure that enum, which is error and OK. Now it turns out that there's a whole raft of different ways of managing errors in Rust, and Rust does a really good job of that compared to certain other languages. It's quite opinionated. It has good defaults, let me say. But what we can do here is we can say rather than using the match keyword explicitly, what we can do is use expect. And so what I'm going to do is delete match, and then I'm going to say what we expect is something. Now the something is just going to be a string that I pass, and in the case where when I'm not able to open the file, what I do is I panic and say that I couldn't open it, and then if I do open it, I return the file. Okay, but what I'm going to do now is use .expect, and if I mouse over that, it should give us something interesting. Unwraps a result yielding the content of an OK. So where it's able to do the operation, it will unwrap the OK and assign it to the variable file. Where it's not able to do the operation, it will panic. And you can see here that that's all I was doing. For my error, I was panicking and I was printing out an error message. And so for now, all I'm going to do is just say expect, but then say couldn't open file if I'm not able to, say couldn't open data file if I'm not able to open that file. Okay. And so basically just doing that, file open .expect couldn't open data file is going to do something really close to what we were doing before with the match statement, but it's a lot more terse and it's quite a bit more readable. And in fact, we can do the same thing here with the file read. And so the file read is going to be similar. We do read to end, and we pass in a mutable reference to the fits data vector, which is created here. And then if we're not able to read the entire file, we just panic. And otherwise, we just print out the number of bytes that we're able to read. And so there's a better way for us to be able to do this. We can do something like this. We can say, let bytes equal, sorry, the typing here. Let bytes equal file read to end. And then we can just do a similar thing. We can do expect and couldn't read file, or something like that. Let's just say, we'll keep it consistent, couldn't read data file. Now, we're not getting the same level of detail in our error message. We're not printing out the data path and the description, but from a readability point of view, it's a single line that does effectively the same thing. Now, there are other ways of dealing with errors in Rust, but this is quite a terse and I think quite a nice one. And so what we can still do is, well, actually, let me go back. We did have something we wanted to keep. Yes, we had a print line. So let's keep the print line macro. And what we'll do is we'll still do print line successfully read number of bytes, and then we can still do data path dot display. Okay. So what we've got here is a data path. We're opening the file and using expect to handle where it's not able to do that. It'll still panic. And if it's okay, it'll unwrap it and put it in file. We're creating a fits data vector, and then we're doing the same thing with read to end. If we're not able to read to end, it'll panic and say couldn't read data file. Otherwise, it'll print successfully read number of bytes from, and then the data path dot display. So this is kind of effectively the same code that we had before, but a lot more succinct, and then I would argue probably a lot easier to reason about. All right, so let's just save that. Now, when I save that, you could see the formatter reformat my code for me. Look, it's a little bit weird, but I'll get used to it. And so, all right, let's see if we can still run this. I'm sure it'll be okay. So we'll do cargo run. Okay. We're not using error anymore. That's okay. We can probably get rid of that. But it's telling us exactly the same thing, which is promising. So let's get rid of this import. We don't need it anymore. Okay, good. So we're able to run our code, and we've saved some lines of code. Happy days. Now, the next thing that I wanted to do was to think a little bit more about this enumeration and this iterator that we're doing over fits data. And so I just used a for loop because that was what I understood. I got some feedback that there is another way of iterating over a slice like fits data, because fits data is a slice of these unsigned 8-bit ints. And what you can do, or sorry, it's a vector of unsigned 8-bit ints, or a vector of bytes. What you can do is use something called chunks. Okay, and so it turns out if we look at, let's have a look at Rust chunks example. Let's have a look. So standard slice chunks is an iterator of a slice in non-overlapping chunks, chunk size at a time, beginning at the beginning. And if it's not evenly divided, then the last slice of the iteration will be the remainder. And so this is kind of cool. I don't know if it's more performant, potentially, but certainly it's interesting. And what we're going to do is kind of quite deeply change the way we were doing iterators here. And so what we're going to do is we're going to still need an index into the iteration. And so we're going to call it a block index, and we'll just say it equals 0. But then what we're going to do is we're going to use the fits data vector, and we're going to call chunks on it. And the chunk size will still be block size. So we're still going to step forward through the vector block size at a time, which is this constant here, which is 2880, so 2880 bytes. But, and we still want to enumerate, we still want to get an index into the vector. But what we're going to do here is we're going to use a combinator called map. So map allows us to pass, in this case, a function, or what we're going to do is pass a closure. So what does it say here? Takes a closure and creates an iterator which calls, okay, yeah. So we're going to create a closure. Now, the way that you create a closure in Rust is by using this sort of bar syntax. And so we're going to create a closure, and there's two things we're going to step through in this closure. We're going to step through, well, there's going to be two things we care about. The index, which will come out of enumerate, which is the iteration count, and then also the chunk, right? We're stepping through block size at a time, and so we want basically a variable that gives us a reference to that chunk or that block of bytes. And so we'll do a tuple, and we'll call the index I, and we'll call, actually we'll just call it chunk, I guess. That's probably more obvious. Okay, so what this is doing is saying map a closure, and so the closure will have a body, and map that over every chunk, and the closure will close over the environment, so we'll get access to the environment that the closure is running in, and we'll also get access to the iterator or the index, as well as the every 2880 bytes in chunk. Okay, and so what we're going to do is create something in here. Well, let's just keep it really simple. So we'll just do, let's say, print, I don't know, we can call it processing chunk. And then let's say, I don't know, the index, yeah? Okay, cool. All right, so what I'm gonna do is I'm just gonna actually get rid of this. Comment this out. So fits data, chunks, block size, enumerate map, this closure, which just basically prints the number of, or the index for the chunk. Now this isn't going to be good enough because chunks returns an iterator. Let's just see what happens here. So let's run that. We'll do cargo run. Okay, ignore that. So it's giving us a whole bunch of, okay, we're not using it, so it's saying prefix, okay. We don't need header, okay, that's fine. Okay. So we're not using it either because it's lazy. All right, so we'll get into that in a sec. All right, let's fix that now. So map basically will. So Rust is really clever. So Rust is able to create these closures with virtually no overhead. I think zero overhead, in fact. And so in other languages like Go, closures can slow your code down. There's a degree of overhead. The runtime needs to manage that, and so there's some complexity there that using closures extensively can actually be slower than just using say for loops. In this case, a for loop probably in Go, I don't know, but a for loop in Go would probably be faster than this kind of idiomatic Rust code. But in Rust, it's able to effectively compile this to machine code that would be as quick and as efficient as something that we would write in a for loop ourselves. But map doesn't actually do anything. So if you think about it, what we're doing is we've got all this fits data and we're stepping through in these 2880 byte blocks. Map is going to define what, or the map with the closure is going to define what we're doing on each of those blocks, but it won't actually run. It's lazy, right? And so for us to force this to run, we have to call collect. So collect will basically force the map to run over the fits data vector in the chunks that we specified. And now I've got an error here. Let's just see why. Let's see what the error means. I'm sure we'll get something interesting. Okay, good. So it needs a type annotation, right? And that's basically because it doesn't know. It basically doesn't know what it should be returning. And so there's a couple of options here. What we can do is we can annotate the collect with a type, or we can do something like this. We can say let I don't know what we're going to call this thing. Basically, we're not going to use it, so we'll just call it something like underscore chunks, and it's going to be a vector, but it's going to be a vector of it's going to be like a vector of kind of vector of units, I think is probably how you would say it. And so now collect knows basically this statement is going to tell collect what type it needs to understand, and in this case we're just basically going to do a vector of these kind of vector of units, a unit vector, and we're going to effectively discard this because map will do some side effects that we care about, and we're not really returning anything that we're going to be processing. All right, so let's try and run that again. Okay, now what we're able to see here is that it's running map, and it's calling that 24 times. So there are 24 by 2880 bytes of data that it's read. Ignore this for now, number of records. That was something that was relying on a global variable that's kind of not being updated anymore. So we've got some code now that is already iterating over our entire fits data in terms of these 2880 byte blocks, and we're using map. Now we need to do a little bit more than that. So map needs to be a little bit smarter because there are going to be different types of blocks or units, if you like, that we want to understand in our code. And so what we're going to do is we're going to use something called an enumeration, and this is basically going to represent the different types of units inside of our fits file, and it'll become clear in a second. So what I'll do is I'll call it fits. I'll do a num fits section or something like that, and then inside of a fits section we'll have three different types. We'll have a header, we'll have some data, and then we'll have potentially a section, an extension. Now, the reason we want to do that is this is kind of like a sort of a really simple. We'll use this kind of like a really simple state machine, because what we're going to do is we want to, as we go through the fits file, we want to mark each section, and we want to know what's coming next. So at the start, we'll assume we're looking at a header, and then once we've looked at the header, we know we want to look at a data unit, and then after that, we might want to look at an extension. And so this is a nice structured way for us to start managing or setting state as we're going through the file. We could just use global variables or something like that and have a number of these things, but that gets a little bit messy, and an enumeration like this is just a little bit cleaner. The cool thing about using an enumeration as well is, remember the match expression. It lets us match against one of these enumerations to destructure it and then sort of understand what state we're in at a given point when we're parsing the fits file. And we're not built, this is not a real state machine. We're not going crazy and doing like a regular expression or a proper parse or anything like that. But we're keeping it as simple as possible without sort of making it super messy. And so down inside of this map, we're going to come across a sort of a number of these sections of the fits file, and what we're going to do is call that state. So we'll say let's state, and the first state we want is fit section header. So as soon as we start parsing a fits file, what we're doing here is saying the first state or the first thing that we want to check is a header. We're going to assume that a header is at the start of the file. We're not validating, we're just making the assumption, right, based on the specification. And so what this lets us do is within the map section is we can then do a match, and what we can do is match on state, right? And the first thing that we might want to match is, you guessed it, fit section header. Now there's also another thing we want to match on, which is, actually, you know what we can do? I'll fix this up in a second. Fit section header, fit section data, fit section extension, and match as an expression. Okay. So what we're going to do is we're going to step through our entire fits data vector by block size in chunks, get an index into that, into which block we're looking at, and then run this closure over every single block that we find. And the closure will give us the index based on this enumeration, or this enumerate, the chunk, and the chunk is something that contains bytes that we care about. You can see here it's a slice of unsigned 8-bit ints. Yeah. So this is already useful, but it's a little bit verbose, and so there is something that you can do in Rust which means that you don't need to use this sort of fully qualified enumeration : and then the member or the item inside of it. You can do something which is, I think it's use creates fit section, and then you can use a glob, and that basically makes all of these items inside the enumeration just available in the namespace or available in the current. Can't type. Create. Available in the current program. And so this means that we can do things like this. We can say state just equals header. And then down here we can say match state against header, match it against data, match it against extension, and things look a little bit cleaner. Okay? So let's just make sure that this program still runs, which it does. Fantastic. We're still processing 24 chunks. Happy days. Now what we're going to do here is, remember for our header, we were stringifying the header down in here. If we look at this commented out code, and we were sort of pulling a slice out of fits data, and we were then we're stringifying it so that we could run contains and looking at whether or not it contains certain strings that the specification told us about. So we're going to do something similar to this, and we're going to do that inside of the header block. So if we get a header, what we're going to do is we need to still stringify, don't we? So we still want to stringify this sort of slice, and we still want to check whether or not it contains the end keyword. But we've already got the slice, right? That's basically what chunk is. So what we can do is we can just do if chunk. Well, let's do if stringify chunk contains, and then we'll still use the same pattern that we had. If it contains end, oh my goodness. Sorry, I'm a newbie when it comes to using this Vim mode, it seems. So if stringify chunk contains end, then we want to do something. And rather than parse it in line, what we're going to do is we'll create a function called parse header, and we'll basically pass in the block of code that we care about. the block of, the slice of data that we care about. Now, okay. So this is why we use block index, because we want to track where each of these blocks or units starts. And that's because we want to be able to then kind of slurp up all the bytes from that block index to where we find, say, the end keyword. And so what we're going to do here is we're going to pass a slice, which will be from block index to, so it'll be from block index all the way through to block index plus whatever the current iteration is, or the current index, plus 1 times by the block size, I think. Let's have a look. So okay, oops. All right. So this, I think this should work. we'll find out. Okay. And then what we'll do is we'll then say that we've found the header, and so what we want to do is we want to say that the next state that we care about is probably data. We're going to say that the next thing that we expect is going to be a data unit, and then what we want to do is update the block index. And so effectively what we're doing here is stepping through by block size these chunks, and for every chunk we're basically we have an index, right? So we're I number of blocks into the file, and we're starting from block index of 0 the first time we pass through this and find end, and then we're going through to, well, 0 plus whatever the index is, plus 1 because it's a 0 based index, times by block size, which is the number of bytes. Okay, so this is basically going to be a slice. The first time we find a header at the start of the file, it's going to be something like from 0 through to, I plus 1 times, the block size. And we'll sort of pass that to a function. And so let's create that function. Okay, so we're going to do a function called parse header. And this thing takes a data, which is a slice of U8, and doesn't return anything. Let me just kind of fix this up, because we're going to change this quite substantially, aren't we? We still have parse record and stringify down here. And so parse header is going to do something like what we were doing here. Right, so parse header is basically going to do what we were already doing down in here, which is this block of code, which I can just sort of probably just copy and paste. It's a bit naughty, but whatever. This is not right. Okay, so I'm going to change this to data, change this to data. We're not returning anything, so we're creating a hash map, and I understand this doesn't make sense. Okay. And I think we could probably improve parse record as well. We'll get to that in a sec. What have we got? What's it complaining about here? It's saying that parse header. Oh, shit. Okay. Sorry, we've got to do fits data. Right. So it's a slice of fits data. Yep. And then can't assign to state, so state needs to be mutable. And then block index as well probably needs to be mutable, I suspect. Cool. So we're getting the hang of Rust mutability. All right, so what we're doing now is we've improved our error handling and made it more succinct, where we've created an enumeration that kind of represents the different states that we'll be in as we parse the file. We'll be looking at header, data, or extension. Then what we've done is we've used chunks rather than using a for loop with step by. We're using chunks to then also create an iterator that gives us the iteration count, and we're using map with a closure that then does a match against that enumeration that sort of looks at state. And if we're looking at header, then what it looks for is something that has end in the string, and then if it finds that, it assumes that's the end of the header, and so it slurps up all the bytes from where we started, which in the case of header was 0, right through to the end, sets the next state to data, and then updates the block index so that we know that the next time we want to do a big slurp of bytes, we slurp from the end of the header. And then we've pulled out parse header into a function that just basically does what it was doing before, except we're passing data. And so this isn't very useful yet, but actually if we just print out what we get, we should hopefully get something useful. Okay. So let's just see if we run this, what do we get? So cargo run. So we actually still get a program that works, which is kind of exciting, I think. So read bytes, processing 7 chunks, and then basically processes or parses the entire header. If we go to our file and just look at what the last thing in the header was, it was the sequence name, and we get that here, sequence name. So great. So we're actually parsing the entire header this way using this this map with the closure. Now let's try and, so this is Clippy telling me that it's not happy, or there's probably a more idiomatic way to write this. And in fact, the person that gave me some of this great feedback sort of told me that there was a better way to write this as well. And what it's effectively saying is I'm trying to destructure a single pattern, and when I'm doing that, there's actually a shorter way of doing it. There's an idiom called IfLet, and so what you can do is you can basically say IfLet some record key value. So you still use this kind of structure. So you say IfLet some value equals parse record. So if you're able to parse the record and assign it, then you can continue, right? So I'll show you what that actually looks like. So it's something like IfLet, and then we basically want this. Oh, that didn't work. I'll type it out. So IfLet some record key value and then we can just say equals parse record. Then we can just do that, something like that. Because what we want to do is call parse record, and parse record, remember, basically tries to parse the string and optionally returns a sort of a record struct with key and value assigned, and if it wasn't able to split based on the equals character, then it returns none. And so IfLet is just a more terse way of basically doing that, where there's no other option, where it's just sort of a single match. And so that keeps Clippy happy. So let's just let's make sure that still works and runs. Yep, great, happy days. Oh, hang on, let me make sure that I've saved that. Okay, good. Yeah, so that still works fine. Okay, good. So anyway, and so now we've got a little bit more of an extensible parser, at least, with a very simple sort of state management idea in there using the enumeration. What I'm going to do now, what I'd like to do now, is add something for extension and for data. And so let's go back up to our match. So what if we get data? Okay. Or what if we get extension? So let's say if we get extension, well actually data is probably the easy one. We're not going to handle data today. We're not going to try and start parsing the binary. But what we will do is we will need a parse data function of some sort. We will still want to update the state and say that the next thing we might want to look for is an extension, and then we'll still update the block index to whatever the current index is. Now what does parse data need to do? Let's add a new function down here called parse data. We'll still take something called data, which will be a slice of bytes. If I can type. But actually, parse data, let's just say parse data will return, I don't know, like the number of bytes or something. It doesn't really matter for now, because basically this is going to be a stub. So what I'll do is I'll just say parse data returns usize, and then I'll just say just return 0 for now. It doesn't really matter. And then so up here, parse data will want to say let data size equal parse data. Now, so we're gonna see some reuse here. Basically, we want to take the same sort of slice. Okay, so we want to basically take another slice of fits data from the current block index using exactly the same kind of formula, the same kind of idea, I think. Well, actually, maybe not. Actually, we should probably be able to compute this based on what's in the header. Regardless, let's just leave it like that for now. All right, so that's our stub for data, and then we want to do something similar for extension. All right, so what we're going to do is we'll have a parse extension function for now, and it will, I guess, probably do a very similar thing. So let's just do, let's just copy this again. This looks like we could probably have a single parse function, right? And then type, and then maybe pass the type of data that we're trying to parse. But anyway, so we'll do function parse extension. Again, we'll pass the same kind of slice, and we don't return anything, I don't believe. But parse extension is something that's a little bit more interesting, because with the header we assume that we're starting at the 0th byte, or the start of the file. With parse extension, what we're actually doing is we're looking for a keyword. So okay, we've got header, we've got binary data, and then down here we look for something called extension. This is like a keyword that we care about. But that represents the beginning of the extension, and then the extension is still matched with an end. So the end of the extension, sorry, still uses the keyword end. And so if we think about it, what we want to be able to do is, if our little sort of state machine tells us that we care about extensions, right? We've looked at header, and we've looked at data, and then now we're interested in extension. We're looking at extension. What we want to do is say, if we want to find that in the chunk, we want to find whether or not it contains this extension keyword, don't we? And if it does, then well, I mean, we know we're an extension. And And then what we want to do is we want to keep looking to see whether or not we can find an end keyword. Now I know this is probably redundant and there's better ways of refactoring this, but bear with me. So, okay. So this is interesting, right? Because what we want to say is, if we find an extension, then yes, we're an extension. Great. I mean, that feels redundant given that we just said that in data, but whatever. We're kind of just finding the extension keyword and we're happy. There could be a bug here, right? Where we look at data, we set the state to extension, we never find an extension keyword, and then we do find end, and then we parse it. So that's potentially a problem. So yeah, anyway, there's probably a bug in there. Anyway, we'll get to that. We'll fix that at some point. So actually, so let's just say it seems possible to hit this block and try and parse an extension without actually finding an extension keyword. So I would say fix fix this. Fix this. And check. Okay, cool. All right, but anyway, we're just going through it quite quickly. So let's see what we can build here. So parse extension doesn't do anything at the moment, but it should. I don't know. We can make it. We can make something. We can make it print something and see if there's. See, you know, just to prove that we've found it. But what do we want to do? So if we find an extension, what's the next thing that the parser might want to find again? I think it's possible that it might find another header, but I need to double check the spec. But anyway, what we'll do is we'll just say, look, the state that we should be looking for next is header. That's probably, it could be wrong, not a big deal. And then we'll update the block index again. And so we've got a bit of a bug here. This whole state thing doesn't seem quite right to me, but we'll go with it. And then down in parse extension, what we're going to do is we'll just say print line. We'll use the print line macro again, and we'll say something like found the end. I don't know, found extension end. Something like that. Parse data, we could do print line. Parsing data. We still return 0 there though. And then header. Let's put a print line in here to say found header. Found header end. Okay. So I think that's useful. So what we've done is we've now got this it's an increasingly large closure, but we're then matching on this state enumeration header data extension. If we find a header end, then we parse it, and then if we find a data block, this is not correct, but we'll do something. And then if we find extension at the start, then we know we're in extension. If we find the end, then we know that we can parse it. There's a potential bug here. And then what we'll do is we'll go in and parse the extension, and we'll just for now just say that we found the end of the extension, right? Because that gets called when we found end. All right, so I think that's looking okay. So let's try and run that. See what blows up. A whole bunch of stuff happened. Let's I'll comment out that print line in the header, so it's a little bit less noisy. Oops. Some time to cargo run. What did I print? What did I do? My goodness, I'm not paying attention. Coming out the right part. So okay, so what have we got? We've welcome, read bytes, we processed 7 chunks, then we found the header end. That's weird. Processing chunk 7, parsing data. That's interesting. Let's just do this. So we'll do print line when we find the extension. So let's say found extension start. Okay, what do we see here? Interesting, parsing data. So we're getting 7 chunks in the header, and we're getting another chunk. Parsing data. Yeah, so that doesn't seem quite right. And then we find a whole bunch of data, and then we find the extension start, and then we find 3 of those chunks, we find the end, and then there's something after the extension by the looks of it. Yes, there was this data here, cool. All right, so a little bit weird, but not the end of the world. I'll just fix that up. Okay, all right, so so that's okay. So this is actually wrong. Yeah. Anyway, it's fine. We'll sort that out. Sort that out later. Cool. So what did we do down here? There was a whole bunch of stuff here that we were doing to create a hash map. We're doing that already. We've got all of that. We've changed that to be IfLet. So we've actually improved this quite a bit, I think, from a Rust, idiomatic Rust perspective. So I'm just gonna get rid of all that code. Now we're also getting some other errors here. So let's just go through and look at what some of these these seem to be Clippy warnings. So we'll go through and look at that. So starting at the bottom here, we've got an unneeded return statement. Okay, so what you can do in Rust is basically just return something like that. You don't need a return statement for it, but you don't actually need the let block either, because what you should be able to do is just, or the let statement, you should just be able to construct the string like that, and literally just return a string. So we're basically passing in the slice, and then we're saying create the string from UTF-8 lossy with this data. We're cloning it into a new string and just returning it directly. So that's cleaner, and we don't need that let s equals and return s. That's just it's a bit cleaner. Now here it's saying that we have an unneeded return statement. So I guess again we can probably just do this. So if we get if we're able to construct a record, then we just pass some r, otherwise we just pass none. And then here it's saying single character string. Okay, so here it's saying that we don't. We can just do this. I think that's what that means. Probably the same thing here. Cool. Okay, that got rid of those particular warnings. Here data's not being used, so it's saying, prefix it with an underscore. That's fine, whatever. I'll get rid of that parsing data statement. Cool. Yeah, we're not using this. Are we using this anymore? No, we're not. not using that anymore, so we can get rid of that. Fantastic, cool. So let's, so we've refactored the code quite a bit. So let's have a look. Let's just, let's see. So the warnings we get here are just unused variables, which is fine. And then we're reading the file, we've got the number of bytes, we're processing 7 chunks till we find the header. We're then processing a whole number of chunks on the data unit, then we're finding an extension, the beginning of an extension that's 3 chunks long till we find the end, and then we're finding another chunk at the end of the file, which kind of represents, I think, by and large, represents what we want. Now we did have another data example in here, right? The different fits file that I think just had a header and a data unit, and it didn't have an extension or anything. So how about we try, my goodness, that is a very long, can I just copy the, so what I want to do is I just want to try this file and see what happens. So we'll just do this. You know what, we should just pass command line argument. We should just have like a command line argument. We could have a default, and if we pass a file name on the command line, then it reads that. It would save, make it easy to test. So what we're doing now is we're reading 63,360 bytes. We've found a header. Again, 8, well in this case 8 chunks, so a bit bigger, and then just a data chunk with no extensions or anything else. So that looks promising. So yeah, okay, so that's cool. All right, so actually while we've got the time, I know we've gone a bit long, but what I want to do is play around with adding just something very simple on the command line that would potentially help us to sort of test this. So there's something that is called standard env. I'm going to add standard env, and then what I'm going to do here is I'll basically print something that sort of shows us how many arguments we've got in our file. So it's going to be let args, how many arguments we have on the command line. So I'll say let args, and then I'll do a vector of strings, and then I'll say that equals env args, and then that's an iterator, so I'll do collect on that. Okay, so this args vector should contain all of our args, and so I'm just going to do print line, and then I'm going to do args, just see what we get. And so what this is doing is basically a pretty print, or a formatting print. So I can pass in a data structure like vec that knows how to be sort of displayed, and this will actually display it for me. So when I'm debugging things, that's going to make life a little bit simpler. So let's try that. So here we can see we've only got a single argument. So arg0 is the actual command line tool, target debug fits rust. So if I was to pass in something like data / and whatever that, what was that file that we cared about? Let's do cargo run data dot fits. So we can see when I pass an argument with the file name, data, and then that fits file, at least args knows about it now. So it's got a vector of 2 elements, and the second one is the one we care about. So what we're going to do is we'll pull out args1, and we'll use that. And so what we can do is, Rust is kind of cool. So we can, it has some more expressive idioms. So we can do let file name equal, and then we can do a if statement here. So we can say if args length, making mistakes. If args length is greater than 1, then we want the file name to be args1. Otherwise, we'll just do whatever we had here. So let's go with data. We'll keep our default as this one. Oops. So we'll keep our default is the original file that we had. Hang on, was that the one? No, got the wrong one. This one. Oop. That fits. I think that should work. So that should do something. Oh, hang on a second. Do I need a... if and else have incompatible types? I don't know if args... what does args give me? What is args? Oh, it's a string, right. Okay, so we want to slice, string slice. Okay. Okay, so, all right, so what I'm doing here is I'm saying, creating a new variable called file name. If we have more than one argument, then I'll just assume that the second argument is a file that we want to process. It's just a convention for now. We could do proper command line handling later. And then, rather than do let data path equal this thing, what I can do is I could just do, I should just be able to do file name. That should work. And so this means that by default I'll still use that fits file, but if I pass in another file name on the command line, it should start parsing that. So let's see how that goes. Okay, that's great. Oh, good. Okay. So it wasn't able to find that file. Makes sense. Because I didn't have the fits extension. And if I just run it without, then it'll just use our default. Okay, that's good. So that means in the future we can just do cargo run, and as we add more data files and fits files, we can start testing that against other fits files. All right, so so we've covered quite a lot, haven't we? Look, I know I rushed through a little bit of that, but a lot of this came from pointers that you, the viewers, albeit a very small viewership at the moment, have been giving me, and I really, really appreciate it. Like, I've learned quite a lot by just reading through a couple of the private messages and then sort of learning from your experience, and you certainly, a few of you have done a lot more Rust than me. And I think what we've got here, albeit a slightly longer file, is probably more idiomatic Rust, maybe. I'm sure I could do better than this yet again. I'm not going to keep refactoring, but if I get really good feedback from you, I will take that on board and I'll try and sort of fold that into future videos, and I appreciate it because I'm learning, so thank you again. And if we review what we've got here now, we've now got a main function which does quite a lot. We've pulled out a couple of functions. We've got parse header, parse data, parse extension. These are stubs for things that we'll work on in the next video, particularly parse data. We're going to start converting that binary data into something that we can display as an image, hopefully. And then parse record, which we had before. Stringify we've improved because Clippy told us a bunch of things that we could be improving there. And then the kind of the core of it is really this enumeration, which we may go away in the future. I'm not convinced we'll keep it, but it helps for now, which specifies the types of things we'll be looking for as we parse fits files. And then more importantly, this chunks idea, which we use map and a closure to match on different states for the parser, and for headers we do something separate to data to extension and so on. And we now have, I think, a more robust program that can handle different fits files. Some, we don't need to have headers and we don't need to have extensions and what have you. It should be, well, actually header is presupposed probably, isn't it? We'll get better at this and we'll make it more flexible in general. But I think we've got a better baseline and framework to work from. And so this is probably where I'll finish this video. And thank you again. Please keep your constructive comments and feedback coming. We will, in the next video, start actually, let's see how we go, but we'll be parsing the bytes in these fits files. And I've been doing a bit of reading of the spec, and it is absolutely the case that the header does tell us how to interpret the data here. And so we'll be using We'll be caring about the endianness of this data, and this is big endian data, it turns out, and so we'll be using this to interpret the data and then turn that into an image. And then it turns out that we need to do something a bit different with this data. This is just coming from a CCD camera, or a set of CCD cameras in the case of the Hubble Space Telescope. And the human eye sees light differently to the way that CCD cameras do. So we'll need to actually apply a stretch to the data, and we'll get into that in the next video. But we'll be able to start pulling out some pretty cool looking images. So I'll upload this to GitHub. Please follow along. Keep learning Rust if you're learning it with me. If you already know it, then please give me more feedback. I'm having a lot of fun. I'm becoming more excited about Rust and learning more about it. I'm starting to think about all sorts of places that I could be using this in my professional job, as well as just for fun. And again, thank you again for your feedback. Please don't forget, if you like the video, please like it and subscribe if you want to follow along and join me on the journey. And see you in the next one.